Hello Year 7s, we are on lesson 7 of the dissolving and separating booklet. So far we've looked at the water cycle and we've looked at one way in which muddy water, dirty water can be cleaned up. And that's what we're going to stay with this now. It's really important to be able to get clean water. How can muddy water be cleaned up? By filtering, of course, but are some ways of filtering better than others? Well, let's have a look. So what are we going to do? Well, number one, we're going to take 10 centimeters cubed of muddy river water. And then we're going to, number two, pour the muddy water through a filter. Now, one way that we could do it is to pass it through filter paper. So what we're going to do is this. We'll take our muddy river water, put it through a filtering system. One type of filtering system is just filter paper. And then what we're going to do on the test tube, we're going to mark off a 1 centimeter depth level on the test tube using a black pen, and using a stopwatch we're going to time how long it takes for the muddy water to filter through the filtering system. Now, I've already said filter paper is one system. Let's have a look at the other two. So filtering system number one is our old friend the filter paper. Number two is rock wool. Now rock wool is number two, is roof insulation. It's like glass fibres. And then number three, we're going to repeat the experiment again using a rock wool plug and then add lots and lots of sand into the filter funnel. So we've got 3 different types of filtering. Let's see what happens in the video. Okay, here's the experiment. You can see that the test tubes have been marked up near the bottom, 1 centimeter cubed, with the black pen. And then we've got our three filter systems. From the left, filter paper in the funnel. Then number two, you've got rock wool in the middle. And then on the right hand side, you've got a rock wool plug at the bottom of the filter funnel. And then we've added some sand. So let's play the video and see what happens. Adding in 10 centimeters cubed of muddy water, starting the stopwatch. And you can see the rock wool stop first, and then the sand allowed 1 centimeters cubed to filtrate through after 4.5 seconds. And the filter paper is taking much longer to allow the filtrate to filter through into the test tube. Clear results there. You can put the times into your results table and look at the filtrate. How clear is the filtrate? On the left hand side, nice and clear, very cloudy in the middle, and then quite cloudy, slightly cloudy on the right hand side. So let's now go back to our results table. You can fill this in. So we can clearly see that the rock wool allowed the filtrate to pass through more quickly than the other two. However, if you actually look at how clear the filtrate was, this was clear. The middle one, the rock wool on its own, very cloudy, not very good at filtering. And then the sand and the rock wool was slightly cloudy. So let us move on. Which filter was the best in terms of speed and how clear the filtrate was? The quickest filter or filtering system was the rock wool. At only 3.7 seconds. Notice that I'm using information from the results table. However, the clearest filtrate occurred using the filter paper. Now, something for you to have a go at here. How many words can you make using the letters in the grid below? And then finally, can you get the anagram? What word can you make from all of these letters? I'm going to give you a clue. We have looked at this in the water cycle. Now, I'll give you an example. Here's a 3-letter word here. T. Another one. Oh. I can see pear. P-E-A-R. Okay, you see how it works? So give that a go. Yeah, and see if you can't get also the anagram, which will be the one word that uses all 9 letters. Now, we've looked at filtering. How else do you think we could clean up water? Well, here's one activity. You stir up your beaker of muddy water and just leave it on the bench. Watch what happens. Let's have a look at this video. Okay, here's our muddy water. And it's being timed. And I'm going to move it along. After 8 minutes, it started to lighten. After 15 minutes, it's a little bit lighter. After 24 minutes, it's a little bit lighter still. What's happening here? Over time, the mud particles start to sink due to gravity, and you can see it right there at the start and after 30 minutes. But just the particles are sinking because of their own weight. Activity number 2. We can measure out 10 centimetres cubed of muddy water and put them into 2 test tubes. Add a spatula of alum to one of the test tubes. So this one's got alum. Then what you do is you add a stopper into both, shake them and see what happens. Now let's have a look and see actually what happens in this experiment. Okay, we've got our
2 tubes of muddy water. To one of them we add some alum.
Test tube we're going to add alum into.
We shake both of the tubes.
Shake them for a couple of seconds.
And we just see which one settles first. Alum is on the right hand side.
This is in real time as well. For some reason, the alum causes the mud particles to drop more quickly. This is caused by a process called, and I'm going to say this carefully, flocculation. More about flocculation in a couple of minutes, but you can see the rate at which the mud particles are dropping on the right hand side, the one with alum in, is much quicker. And finally, activity 3. The teacher will pour a beaker of muddy water into the top of the model gravel bed. Watch what happens. Now the gravel bed is made up of a big cloth plug at the bottom, and then you've got bigger bits of gravel in this upturned glass vessel, and then you've got several centimetres of sand. Okay, and we're going to pour in the muddy water into the top and then see what comes out at the bottom here. Let's have a look at this video. Not very well, but it's been filtered. So activity 1 was a reservoir. That means that the lake is going to be very deep. You've got your water here like this. I think that storing muddy water in a reservoir that's very deep does get rid of the dirt, because under gravity the mud particles sink to the bottom. In other words, you had lots and lots of mud particles in here to start off with. They all sink to the bottom under gravity, and so eventually what happens is the water in the reservoir becomes clearer because all those particles have sunk to the bottom. Now, number 2, adding alum. I think that adding alum to the muddy water does get rid of the water, because the mud particles stick to the alum particles I'm going to leave it at that for a second. I'm going to come back to activity 2 in a moment to fully explain it. And activity number 3, do this in a slightly different colour. The gravel bed. I think that pouring muddy river water through the gravel bed does get rid of some of the dirt, because the dirt particles get trapped between the sand and gravel. Okay, now let's go back to activity 2. Add the mud particles in the diagram below to show what the alum does when it causes flocculation. So these are the alum particles. The mud particles I will show as this, okay, with a little spike on them as well. And what happens is you add the alum to the muddy water, the mud particles are attracted to the alum, and under their own weight they're going to fall down much more quickly to the bottom. So on their own the mud particles would sink, but because their mass is small, they don't sink very quickly, whereas these particles are much, much heavier and they're going to sink much, much more quickly. I hope that makes a little bit of sense to you. Now, this process by which the mud particles are attracted to the alum particles is called flocculation. And that will do for today's lesson.